So in this lesson, we are going to understand what is the meaning of supremum of S. Supremum of S. So based on supremum of S, we are going to do this question here. Let S be a set of real number that is bounded above. Define what is mean of supremum of S, and we are going to do another question based on this. So here I have taken S be a this is S, set is S, n over n plus 1, and based on this we will do these two questions. So let's start the first question here. So here S is a set of real numbers given, and also it is bounded above. It means there is any real number will be an upper bound of this set S. So let's take S is a set here. So 1, 3, 5, and 7. Okay. So this is a set S, and 7 is the greatest element I have taken here. So it means every element of set S is less than or equal to this 7. Okay. So maximum element of this set is 7. So here is the set 7 is 7 will be the upper bound of this set S, because each element of this set S is are smaller than this set S. So 7 is the upper bound of this set. Also, any set, and this is 7 is the upper bound of this set S. So you can say that this set S is bounded above. Bounded above. So the set which is bounded above has an infinite number of upper bounds. You can understand this is, so any set which is bounded above, as you see that this set is bounded above, so this set has infinite, this set will have infinite number of bounded above, this set have infinite number of upper bound. So there will be a special upper bound in this infinite number of upper bound. So we are going to do this one. Let's understand by taking a set here. So let's set S equal to 1 over n, where n belong to natural number. This is a set. Define this set. Substitute n equal to 1, 2, 3. So you will get 1 over 1, 1 over 2, 1 over 3, 1 over 4, and this way you can go to till infinity. Okay, let's define this on a number line. So here is a number line. This is 0, this is 1, this is 2, and this side -1 and -2. 0 here, and 1 over 1 is 1 here, and then next element is half. This will be 1 over 2. Then 1 over 3 will be little less than half, 1 over 3, then 1 over 4, 1 over 5. Okay. So if this set is coming to from this way. Okay. So what does that mean? 1 over infinity. If you go to 1 over infinity, 1 over infinity is, you can say that it is tending not equal to, you can say that equal to 0, but not equal to 0. It is tending towards 0. Tending towards 0. Okay. So these are the how to define X. X is the element of S. This is X is the element of S. X is the all the element of X will be less than or equal to 1 for all X belong to S. Okay. So all the element of X will be less than or equal to 1. So you can say that 1 is the upper bound of this set. Upper bound of this set. Okay, so 1 is the upper bound of this set. So this set is bounded above. So you can say that this set is bounded above. Okay, and the set which is bounded above has an infinite number of upper bounds. So upper bounds of this set, you can say that all the element this side, all will be upper bound of this set. Okay, all will be upper bound. So all from all the upper bound of this set, this is the least upper bound. This here all the numbers will be upper bound of this set, but this is the least upper bound of this set. So we can denote it L U B, or this is the least upper bound is also called supremum of S. So supremum of this set S. Okay, and supremum of S is the least upper bound, and then so this one is belong to this set S. So one is also called greatest element of S. So don't worry about these words. You can understand only bounded above, and this is the supremum of S. So we will explain this in the next question. Let's take next question here. So next question is, let S be defined as follows. So S equal to the set S is given n over n plus 1 such that n belong to natural number. So first question here is, state the value of supremum of S. We have to find the value of supremum of S. So let's take S equal to n over n plus 1. This is the set S and n belong to the natural number. First, define the set, substitute n equal to 1, 2, 3. So 1 over 1 plus 1, first element will be 1 over 2. Then second element will be 2 over 3. Then 3 over 4, 4 over 5, 5 over 6. And this way it will go. Let's in between, we will get 1000 over 1001. And this way it will go on. Define this on number line. This is the number line. Let's take 0 here and 1 here, then 2 here, minus 1, minus 2. Okay. So first element of this set is half. Second element is 2 over 3. So it will be slightly bigger than half. 2 over 3. Then here 3 over 4, 4 over 5, and this way it will go on. Calculate this 1000 over 1001. If you take calculator 1000 over 1001, you will get 0.9 something. But it will not be equal to 1. Okay, it is, you can say that this set is tending towards 1, but not equal to 1. So you can say that this is the supremum of S. This is the upper bound of S, least upper bound of S. All the number tending towards this way. So this is the maximum of these. All are upper bound here. All are upper bound, but this is the least upper bound. But you can say that one is not belong to this set. How this will be upper bound or supremum of S? There is two main point to understand about supremum of S is, supremum of S may or may not belong to set S. So supremum of S may belong to set S or may not belong to set S. So this is the first point we have to notice. And second point is, if supremum of S belong to S. So if this one is belong to this set S, then it is called or said to be greatest number. So in the first question I have explained here, see, I have taken s equal to 1 over n. Okay, and here 1 is the greatest number, and this is also supremum of s, but this one is belong to this set. So this is supremum of s. So you can understand supremum of s is may belong to or may not belong to the set. So here supremum of s belong to this set. If supremum of s belong to the set, this is the greatest number of the set. Okay, but here in this set, this greatest tending towards 1. Okay, it means 1 is the upper bound. Okay, but this 1 is not belong to here, but this is not called, you cannot say this is the greatest number of the set S. Okay, because this is not belong to, but this can be supremum of S. So what is supremum of S here? You can write it down. Supremum of S here is equal to 1, or this number, this question, state the value of supremum of S equal to 1. Now we will do the second question. So we have to prove that the value you stated for supremum of S in part 1 is correct. So we have to prove here proof. What we proved here in part 1, supremum of S equal to 1, and we have to prove in this part that is correct or not. Okay, let's write down all the element here. So 1 over, first element was 1 over 2, 2 over 3, 3 over 4, and this way. So these elements, so you can understand what we have taken here. In between we have taken 1000 over 1001, and this is go on. Okay, so you can identify from this set that these elements gets closer to 1. Okay, for larger value of n, we are just substituting n is larger value. Here 3 is larger than 2, 4 is. So for larger value of n, this set is getting closer to 1, closer to 1. So what we have proved here, 1 is the upper bound. This we proved here. So 1 is the upper bound of this set. Upper bound. So what was the set here? N equal to n over n plus 1 in first part of the question here. It means 1 is greater than or equal to n over n plus 1, because 1 is the upper bound of set S. So for all n belong to natural number. It is clear that if you divide any natural number by bigger number, so this is natural number and we are dividing this n by 1 bigger than this number. By bigger number, you will get number less than 1. Every time you will get number less than 1. Okay. In other words, you can understand, you can't divide one number by bigger number and get something bigger than 1. Okay. So here 1 over 1, let's make it fraction, and this is the inequality sign here, and cross multiply. If we cross multiply, you will get n plus 1, n plus 1 come over this side, greater than equal to n. So here, if we cross multiply, what we get here exactly what we want here. N plus 1 is greater than equal to n. Okay. And now what next step you can divide this n plus 1, both sides, let's divide by n plus 1. So n plus, we are doing same thing both sides, so no problem here. So n plus 1, so this is will be cancelled. So 1 is greater than equal to n plus 1. Okay, so here, either way you can prove that. So here you can say that 1 is indeed upper bound of the upper bound of this set, the set S, and it means 1 is supremum of S, and which is correct in first part.